Hello, everyone. So today we're going to do it a little untraditional here with going through the lesson through Zoom. So the first thing you should be looking at is the Unit 4 Day 13 notes. This is specifically on the quadratic formula. Now we're not going to finish these all the way through, but we're going to kind of hit the major thing with the quadratic formula and then talk about some specific details about the quadratic formula starting tomorrow. So the first thing that I want you guys to do, if you haven't already, is open up your own notebooks, and I want you to take a look at the warm-up problems. Now, when it comes to the warm-up problems, I would actually like you to pause this video and complete the 4 warm-up problems. So again, go ahead and pause the video, work on these warm-up problems. A reminder, with these problems, you should actually be finding what x equals. These all have equals 0, which means we should be able to figure out what x equals. So again, pause the video, go ahead, go for it, complete the problems. Now, assuming that you have completed the warm-up problems because you paused the video as I told you to do, we're going to go ahead and kind of quickly go through these ones to make sure that you got them right. Now, the first one is a perfect example of pulling out the greatest common factor. Now, there was a couple of these on your quiz, and a lot of people were like, I don't know how to factor these if they don't have the C value. How can I figure out what multiplies to C or the AC method without a C? Well, if you don't have a C, then you should probably be looking for your GCF. So in the first one, actually, the GCF is just an X. So the only thing that we can pull out is an X, in which case we pull out an X from both pieces, and that's technically factored form. As for the answers, we would get one of our answers from out front here, x equals 0, and the other from inside here, which would give us a 5/2. So those are your 2 answers. Second example, this is a perfect example of doing the x method. Since the a value, which is the number out in front, is 1, we can do the x method. So we'd be looking to say what multiplies to 7 but adds to 8. Hopefully you pick the numbers 1 and 7. Therefore, our factored form would be x plus 1, x plus 7. No, 1 and 7 are not our final answers. That's just our factored form. What would our final answers be? X equals -1 and x equals -7. Now, the third example, I'm going to zoom in here just a little bit. The third example is a perfect example of the AC method. So really, these are all kind of taking you through the different methods that we know so far in order to find x. So a little reminder of the AC method, taking A times C. By the way, how did I know that it was the AC method? A1, the A value was not a 1. Can't do the X method. There is no GCF, so nothing that I can pull out. So the AC method's all we got. We're looking to see what number multiplies to 6, but adds to -5. So and a lot of times people really get frustrated with this one because they're thinking to themselves 6 and 1. But if you choose a -6 and a +1, that's great. It does add to -5, but it does not multiply to a +6. So in this case, you should have picked the numbers -2 and -3, which again adds to -5, but multiplies to +6. Now, different from the X method, what is this -2 and the -3? That is actually the rewrite numbers. So we carry this down, we carry this down. What happens to -2 and -3? They become this -5x. So a -2x and a -3x is still that -5x. Now, why in heavens do I go ahead and rewrite it? So that I am capable of grouping the first 2 with the last 2. So now that I've grouped these, I can pull out the GCF. So this first one, actually I can pull out a 2. So if I pull a 2x out here, that leaves me with x. If I pull a 2x out here, that leaves me really just with a -1. In the second grouping, what I can pull out here, pretty much just a 3. And I would recommend that anytime your first number is negative, I'd pull out the negative as well. So I'm going to pull out a -3, which leaves me with x. If I pull out a -3 here, it actually leaves me with a -1. Here's the matching pieces that we always look for. So what is your final factored form? we would have this 2x minus 3, and then we would have that x minus 1. Now, again, take that all the way to your answer. What should x equal? X should equal a 3 over 2 and a 1. And then the last one. So the last one, again, going through our different rules, look for greatest common factor. No. Is your a value 1? No. So this would be another AC method. So we go ahead and we start doing the AC method and we get -3. So we start thinking to ourselves, what multiplies to -3 and adds to, well, technically a 1? So really think about that for a second. What multiplies to -3 and adds to 1? When it comes to multiplying to -3, there really isn't that much. We could have a -3 times 1 or a -1 times 3. And that's honestly about it, right? And you probably got a little frustrated with this problem, I imagine, in which case you're really trying here what multiplies to -3 and adds to 1, and you find that even after really spending some time on it, nothing. So this is a problem that we call not factorable, not factorable. And if they actually asked you to factor it, that's what you would say. It's not factorable. But actually, if you if you look back at the directions, it simply says solve. It doesn't say factor. So coming back to this problem, it might not be factorable, but is it solvable? And this is where the quadratic formula comes into play. The quadratic formula helps us find the value of x without factoring. Now, of course, sometimes factoring is great. We look at those first 3 problems. With factoring, we were able to figure out all these answers, by factoring, okay? But the quadratic formula kind of takes that step of saying, well, what about all the situations where factoring doesn't work? In example, the last one. So let's take a look at this quadratic formula. Now, as I mentioned, this is a poster in the room. This is a formula that's typically given to you. SATs, it's going to be on your formula sheet. I don't know, keystones, it's going to be on your formula sheet. It's usually given to you, I would say about maybe 80 to 90% of the time. So it's not necessarily something you have to memorize. Now, some cool math teachers do have a little bit of a catchy beat to helping you remember it. I'm not really great at singing, but I'll do it anyways for you guys. So the song kind of goes something along the lines of the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Like I said, it's not a great song, but it's a little catchy. So let me sing it for you one more time. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So again, if you can kind of get that in your head, I know that when I was your age, I had to learn that song and sing it. Not going to have you guys do it, but still a formula you're going to want to know. Now, there is a lot going on in this formula. So let's kind of dive in a little bit here of, going through this formula. So the first thing we should notice is that it says x equals, whoops, that was supposed to be a highlighter. There we go, x equals, which means this formula tells us what x equals. Now you might be thinking to yourself, well, wait a second, Ms. Mara, you said that we should always get x equals like 2 values, 2 answers. This only says x equals once. So where's our second answer? Actually, what's really cool about this formula is it actually gives you 2 answers. Now, where do those 2 answers come from? This symbol right here, this plus or minus, which basically says that given this formula, there are 2 outcomes. There, and you don't have to write this down, but there is the first outcome where we go through the entire formula, boop, the whole formula, negative b plus square root of b squared minus 4ac all over 2a. We do that once with a plus, and then again, but this time with a negative. Okay, so again, where are your 2 answers coming from? The idea that one is a plus and one is a minus. Now, do you always have to do the formula twice? Luckily, no. Henceforth, why we have the little symbol where it's a plus and a minus. You don't have to do this twice. You just have to do it once. In which case, I would leave the plus or minus in the equation that you're working with, but we'll see how the plus and the minus come out separately in the end here in just a second. Okay, so that's the first important thing you should know about the quadratic formula, is that it will give you 2 answers simply because of that plus or minus. Now that plus or minus only appears once in the equation. Everything else you see, that negative b, the minus 4, that will always stay the negative b and the -4, but that plus or minus should always be a plus or minus situation. What about everything else in this formula? Because, oh man, I'm seeing a lot of variables here. I'm seeing some b's, some a's, and c's. They're all over the place. So it's a little kind of overwhelming and wild to think that we have all these different variables in here. But here's the crazy thing. The a, the b, and the c are not variables. They're actually information that we know. Think back to the very first day or second day of this unit. We talked about what a quadratic is. So we got this kind of equation where we said ax squared plus bx plus c, in which case we used this form when we did things talking about like the AC method or what multiplies to c and adds to b. We were referring to the a, the b, and the c this whole time. A times C, or what multiplies to B and adds to C. We were doing this whole time. So when you're given a quadratic, you can actually look at the quadratic and say, what is the A, what is the B, and what is the C? Keep in mind, by the way, the A, the B, and the C do not have X's. They're standalone numbers. But once you get that A, the B, and the C, plug it in the formula and simplify as far as possible. So let's do one. I think we're ready. Let's do it. Okay, let's look at the first example. Where is it? Here it is. First example, going to blow it up nice and big. Okay, and I'll refer back to the formula here in a second. Actually, for beneficial points, let's write it down. So it says, whoa, that is a big font. Let's make that a little bit smaller here. Let's go this size. Okay, so we have x equals the opposite of b, which I will explain here in a second, plus or minus the square root of b squared minus 4ac all over 2a. And bear with me just for a second here. I'm actually going to try to make that a little bit smaller. Okay, there we go. It just fits on the screen a little bit better. So we have this formula. Again, as I mentioned before, it's very beneficial to kind of figure out what is the A, what is the B, and what is the C. Your homework tonight, you're going to practice this formula over and over again. So let's do one here together. So first things first, what is the A, what is the B, and what is the C? So looking at our problem, a reminder that the A is always in front of x squared. Sometimes it's not given to you, so you have to remember that it's a 1. What is the B? This is technically the 8. And what is the C? The 7. Now let's plug it into the formula exactly as we see. Okay, so we have x equals. Now, here's the interesting thing. This negative b, what it means is, and you heard me when I sang it, the opposite of b, plus or minus, right? It's the opposite of b. So in this case, our b is 8. What is the opposite of 8? Negative 8. Now, what if that 8 was negative? The opposite would be positive. Henceforth, why in the song we don't say negative b, we say the opposite of b, because sometimes b is already negative, so the opposite would be positive. And really that happens because we would have negative 8, which turns it to positive. So opposite of b is just as catchy. So opposite of b plus or minus the square root of b squared. And this time I'm going to write it out. Sometimes some of you will actually just go right to squaring b, but we'll get there. And then you'll also notice I'm going to write out 4 times a times c. Yes, this is all multiplication. And then I take the whole thing and I divide it by 2 times my a value. This is for formula. Now, the big thing with the quadratic formula is A1, setting it up and being able to simplify it properly. So let's get into simplifying it. When we simplify it, we're going to kind of do little pieces at a time rather than try to do the whole thing. So let's start out by addressing the square root of 8. That should be 64. Let's also address this minus 4 times 1 times 7. So let's see, I have a negative 4 times 1 times 7 results in a negative 28. And we're going to put that all over top of 2 times 1, which is 2. Let's keep simplifying. Let's do what's in that square root. So we have 64 minus 28 gives us 36. Not negative, so no imaginaries that we have to worry about yet. Again, keep going. So let's see, let's do that square root now. Square root of 36, 6. And now let's pause for a second here, because at this point, we've kind of simplified everything that's quote unquote obvious. And now we're into the really interesting stuff, because now what we're just looking at is all whole numbers. So when you're working with all whole numbers, we should be able to kind of simplify. So here's the moment where it kind of will break into the positive and negative. You remember how we said that plus or minus symbol represents two equations? One equation where it's plus, one equation where it's minus. Here's that moment. So we're going to break this into two things. We're going to break it into a plus 6, and then we're going to make it a minus 6 down here. So these are really your two equations. And sure enough, let's simplify. So let's see, -8 plus 6 would give you a -2. Divided by 2 results in a -1. That's your first answer. There's x equals -1. What about our second answer? Let's do our second answer. -8 minus 6 results in a -14. Divided by 2 results in a -7. Oh my gosh. There's our second answer. Now, the crazy thing is we just found this whole thing by quadratic formula. But if my computer decides to not glitch, come on. There it is. Okay. But if you go back to the original problem, really take a close look at this. This kind of catches people a little bit. Our original problem was an x squared plus 8x plus 7. Our answers, -1x, equals x, and -7. -1, -7. -1, -7. Oh, look at this. That was actually one of the warm-up problems. X squared plus 8x plus 7. Check out our results. Now, I'm going to zoom out, so it might be a little hard to see the numbers here. But one of the crazy things is up top here, okay, we did it through the x method. Look how quick that was. Multiplies this, gets that, boom, boom, factored, answer. Versus the quadratic formula does take a little bit longer. So one of the things you should know about the quadratic formula is that it works on all quadratics. It's the one thing that works all the time. The x method only works when a equals 1. The AC method, well, that works when you can do the a times c. GCF works sometimes. The quadratic formula works all the time. Now, let's say that you had a problem, going off script here just a tad bit. Let's say you had x squared plus 5. Okay, could the quadratic formula work? Yes. What is the a, what is the b, and what is the c? Excuse me. Be careful. The a is 1, okay, but what about the c and the b? Reminder that b is always followed by an x. We have an x squared, but no x. So what is b? 0. What is c? 5. Counter example, what if I had x squared plus 4x? Again, going through, what is your a? What is your b? What is your c? The a, again, just one of those given examples, is a 1. What is your b and what is your c? Your b always has an x. So in this case, your b is 4, your c, there isn't one, so 0. So the quadratic formula always works if you can correctly identify the a, the b, and the c. Another thing to notice is that when you're looking at, say, the a and the b, we do not include the x squared or the x. We simply take the numbers out in front. Sometimes people try to do the quadratic formula plugging in like a 1x squared. Gets really messy really fast. Just plug in the numbers, not the x, okay? I promise you it makes everything easier. So let's do just one more here together. Boop. We're going to skip to number 3 because actually number 3 was the one in the warm-up that we were not able to do. So let's do this one because again, we couldn't factor it. We couldn't find the answer. Let's do it now. Going a little bit quicker here, we're going to have the a, the b, and the c. So the a is going to be what's in front of the x squared, which is the 3. Do not include the x squared. The b is what's in front of x, in this case, 1. And the c is all by itself, -1. Let's plug it into our formula now. So we're going to have x equals the opposite of b. So this is positive. Let's make it negative. Plus or minus the square root of b squared. B squared is 1. minus 4 times a times c all over 2 times a. And next up, we simplify what we can. Most typically, you simplify what you can do in your head, so to speak. So let's see, I have a negative 4 times 3 times negative 1 actually results in a positive for the record, because negative and negative would be a positive 12. Let's keep going just a little bit further. So let's see, I get negative 1 plus or minus the square root of 1 plus 12 gives you 13 over 6. And now we look at the square root of 13. In the first problem, we had square root of 36. We could do that. We got 6. But this one's the square root of 13. It doesn't really go any further than that. And even if we tried to reduce that square root of 13, there just aren't any perfect squares in 13. So 13 doesn't go anywhere. It's like saying the square root of 3. It just doesn't become anything. Now, just for the purpose of practicing, I want to show you something. But for the purpose of us, this is actually your final answer. When you get it to the point that you can no longer simplify it by quote unquote hand, that's done. If you need to reach to your calculator, you've gone too far, okay? So I just want to show you the idea of what this becomes if I was to find the decimal value, which we will not do. But I just want to remind you that this is technically 2 problems. Negative 1 plus the square root of 13 over 6, and a negative 1 minus the square root of 13 over 6. And actually, just for the purpose of time, I'm actually just going to leave it there rather than calculating it for you guys. If you are curious, you could calculate these, but these will be your 2 values of x. And as I said, you should always get 2 answers for x. Here's your first one. Here's your second one. Now, they aren't pretty, that's for sure, but nonetheless, that is the case. So very last thing for today, we're going to repeat some of this tomorrow. So we've seen the quadratic formula. In your homework, you're going to practice it. You're going to pick out the A, the B, the C. You're going to plug it in. You're going to simplify. Now, one of the problems you might run into on your homework, go into the next page, find yourself this problem right here. Now, let's say you did the whole quadratic formula, the opposite of B plus or minus the square root of B squared minus 4AC. You simplified everything like that. You got it to this point. All right. Now, this is a side example. It doesn't actually even have the plus or minus. So it's not necessarily the quadratic formula, but you could pretend that we had another one over here that was minus, here's your plus version, here's your minus version. But for argument's sake, I just want you to look at this problem. This has been mostly fully simplified. Square root of 24 is not necessarily a perfect square. What I like to point out is sometimes in the quadratic formula, you will get a negative under the square root. I warned you of this. You will get a negative under the square root. In which case, what do we do with that? Guys, come on, negatives under the square roots. What do we do with that? It's imaginary. So it's not necessarily a real answer, but it's real enough to us. We can solve it. So let's pull out an I, because we know the negative under the square root is imaginary. In which case, now we can deal with that square root of 24. I'm probably going to choose to break it into a 4 and a 6. So what would my final answer be here? Well, let's see. Square root of 4 is going to become just a regular 2. Square root of 6, that's just going to be a square root of 6. It ain't going nowhere. Don't forget about that I we found, because it's negative, over 2. Now that would be your fully simplified answer, but there is more. We can do more. So this would be fine in the sense that you pulled out the I. There's one last thing I want you guys to start practicing. You'll actually hit it in your homework a little bit tonight, is the idea that if it is being divided by a number, say 2, and your top 2 numbers, boop, and again, I'm going to focus on the whole numbers out in front. If those whole numbers are also divisible by 2, we could actually simplify this a little bit further, because what they're saying is we could take this divided by 2, this divided by 2, and see what happens. So let's do the 4 first. What is -4 divided by 2? -2. Okay, what about the second piece? Now here's the tricky part. You're going to take that second piece and divide it by 2, but the square root of 6 can't be divided by 2 because it's in the house while the 2 is not. So the square root of 6 is in the square root, the 2 is not, so they're not going to mix, but the 2 that's out in front could be simplified. So what we're going to get is a minus, what is 2 divided by 2? 1 with that I square root of 6. So what would I expect your final answer to be here? This, you don't really need to have the 1 there, so let's take that out. Boop. This would be your final answer, a 2 minus I root 6. Now, again, when you do this idea of doing this bottom number and dividing and simplifying the top, both of those numbers need to be able to be divided by 2. Just for the argumentative sake, let's say you had -4 minus 3I square root of 6 divided by 2. Yes, 4 is divisible by 2, but the 3 is not. So I really wouldn't even simplify this one. I would just kind of leave it as is. But if they're both divisible by 2, then you can simplify a little bit further. So to summarize today, wrap this up here and let you guys get on your way. You guys are going to be practicing this quadratic formula. Again, being very careful with what is your A, what is your B, and what is your C. Do not include the X's. Why are the X's there? Why is the X squared there? Why is the X there? To help us determine the difference between what is the A, what is the B, and what is the C. If they all were just no X's at all, how do we tell them apart? So the X squared tells you that that's the A, the X tells you that's the B, and the one that has no variable, that's your C. But again, it's really just the numbers, not the X. Plug them into the formula and simplify. So that's what your homework's going to be tonight. Actually, I could show you guys here. 5-8. So really, you just have 10 problems going through that A, B, and C. Be careful with some of these. I'm just seeing them at a glance. These ones are not equal to 0. You need to get them equal to 0 first. Then you can go through A, B, C. And some mistakes I've seen in the past is people who go like this, and they're like, oh, that's easy. I can add the 6 over. But then when you're deciding your A, your B, and your C, reminder that the A is in front of X squared, the B is in front of X, and your C is all by itself. So a lot of times it's actually easier if you just write it in the correct order. The correct order for this one would be adding the 6x over and then still having that plus 7. X squared, X, no X. So just watch out for those in the homework. Make sure they're all equal to 0. Try out the quadratic formula. I believe I didn't write it on here, so it's probably helpful for you guys to have it on here. You might want to just copy it down on here. X equals opposite of B, not negative B, opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Okay, so it's important for you to have that down. Practice the quadratic formula, and I will check in with you guys tomorrow.